What? Yeah, right here. Yes. All right, y'all. I got a lot of stuff to do today with acid-base nomenclature, so I'm trying to teach you 2 different ways. The notes in the assignment are up here. For the opener today, and I, of course.
I'm not saying that.
Hello? Yes.
What? That one time we went to New Orleans. That shit was sick. That one literally, I'm not sick of it. That one time the band came. What happens at band camp stays at band camp. What? No, it was like, what did she play? Oh my god. You are nasty. You are nasty. Have you not watched the movies? Yeah. What did she play? I forgot what instrument she played. No. What? It's like, look. Yeah. Was that? I thought it was one of the. I think it's a clarinet. Clarinet? No. The thing with the 3. Trumpet. 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 Really? I don't know. Same thing. It's a movie. It's a movie. It's an adult movie. Yeah, she's your cousin. She plays it. She plays it. Chick flute. I think about American Pie, baby. Yes. Yes. I know the funny story. What happens at band camp stays at band camp. Hey, you're right. Hey, go. That's him on my bed. He was still. I think it was like 3 a.m. What?
I think that's what it is. Thank you. I'm so sorry, y'all. I'm trying to organize my daughter's ninth birthday party, and that was the thing. So, okay, what now?
Yes.
Okay, go really quickly come back. I do not have a pass to give you. My pass has vanished. Okay, so back to this. Like I said, I apologize. I was not expecting that, but I didn't want Kroger to make a double of everything. I feel bad. Hydrochloric acid. Okay, this is what's in your stomach when you eat food. This is what helps brain wash, helps break down the protein that's in your stomach. Just by looking at the name, don't worry about the acid part. Hydrochloric. What do you? It is hydrogen and chlorine. That is exactly correct. So, hydrogen is an H. It's in group 1. So, what is its charge? Okay, and chlorine is in group 7. So, what is its charge? So, what's the formula for hydrochloric acid? What's the formula for hydrochloric acid? No, you don't write pluses. No, you don't write ones.
HCl.
Just HCl.
Oh. What's the?
They add to 0, right?
Oh, yeah.
So we don't, you got to be able to do your charges again. This stuff is coming back. I'm sorry, but I mean, this is chemistry. This is the way it works. So hydrochloric acid is made up of 1 hydrogen and 1 chlorine. The formula, which I put, and I'm sorry, those of you that are remote because it's on the dry erase. The formula, because they already added to 0, would just be HCl. And that is what's in your tummy when you eat food that breaks up the protein. Because you don't, Brayden, you don't break up other things like sugars in your stomach. You break them up other places. We're going to do the easy stuff first. Stop throwing things. Then we're going to get into the harder stuff, which is doing the nomenclature. And I'm going to teach you 2 different ways. I don't care which way works better for you because they're both okay. But there's 2 ways to do this. Acids first. If you put something that's acidic in your mouth, it is going to taste sour, like a lemon or a lime, because they have citric acid in them. Or vinegar, which please don't go try to drink vinegar. You'll throw up. But vinegar is sour too. When you do have an acidic compound, what it does is it gives off hydrogen to make hydrogen gas. This is what makes an acid. It's the hydrogen component. Now, shh. When you do have a carbonate, they're going to make carbon dioxide. That's what happens when you open that soda and the bubbles come out. It's carbonic acid that's in those. Now, indicators, there's a couple major indicators that we use, and I'm going to have to be taking so much because of my cat. I don't know if we're going to be able to do an acid-base lab, but if you have litmus paper is either blue or red. Really, the red one's pink, but it's one or the other. And if you have blue litmus paper and you put something that's acidic on it, it's going to switch it to the pink color or red. It doesn't really look red, it looks pink.
Yeah. I
So-
was playing with some the other day.
Yeah, and I don't know if you've done any of this stuff before. I need to see if there is another one on here. I don't know when you would have done this, except if maybe you took IPC. And IPC is one of those classes that's sort of just like is weird if you take it or not. If you have a substance called phenolphthalein, that's how you pronounce that weird looking word, and it's a clear liquid, okay, and you put it in with an acid, it's going to stay clear. It's not going to change color. If you put it in a base, it turns like neon hot pink. Like bright, bright, bright pink. But in an acid, it doesn't change its color. That's why I said I know. Well, I didn't see you guys yesterday because of testing. And then I didn't see you the day before because I had to take my cat in for x-rays, or the day before because that was the first vet visit. And now I'm gonna have to take off next Tuesday also. So do what? Well, that's why I said I don't know if we're going to be able to fit one of these in. Most of the stuff we've been doing anyways has been digital just because of the remote kids. And it keeps them on the same page. And I know that really sucks for y'all in person, but... Okay.
You make them show up?
So, hold on. Shh. Bases, your pH is going to be under 7. Okay, if it's at 7, that's neutral. It's one of the few things I didn't put on here. Y'all, shh. If you get an acid on you, it's not necessarily going to rip your face off immediately like Phantom of the Opera stuff, but it hurts. It burns. If you do accidentally get an acid on your skin, you're supposed to run it under cold water, not hot water. I hope that never happens to you. So like I said, they give off hydrogen ions. This is what makes an acid is the fact it's got a hydrogen component. Normally the hydrogen is listed in the front. So I got a couple different examples on here. We've got the hydrochloric acid. So for those of you that are remote, the HCl was the formula for the one that was the opener. We have, that is sulfate, 8 is ic. This is sulfuric acid. This is nitrate, 8s are ic. This is nitric acid. That's the hard part. What I just did in my head had to teach you how to name it because there's different rules. And the way I learn it and the way I teach it is different than what you're about to see on the slide because that's the way they teach it here. Both of them are totally acceptable. If you have some type of an indicator, this is the thing that changes color or possibly doesn't change. And that lets you know if it's an acid or a base. Let me do the rest of the in-person here. George is here. I need to check online. Okay. Tiffany's on here. Sebastian's here. Caitlin's not here. Morgan is here. Jared's not here. I saw Ray get on Ron. Valerie's not here. This, I did not see yet. If I'm calling you and you're remote, I haven't had a chance to take a look at the screen again. So give me just a second. Right, y'all. Shh. Bases, on the other hand, this is the other side of the pH scale. Turn the thing on. These, if you put them in your mouth, they taste bitter. Almonds are like this. Ooh, soap is like this. I don't know how many of you have had your mouth rinsed out with soap. That was common when I was a little kid. I don't have to do it anymore. So if you get it on your skin, it's going to feel slippery to the touch. They also affect indicators. Now, this makes the red litmus.
Will the following students
You got
please
to-
report to the main entrance of the competition gym? Keller Bonish, Emily Cole, J.C. Deacon, Dane Doris, Trinity Hall, Cole Hilliard,
Two.
Braden Knoll, Jacob
No,
Lee,
something's going on right now. It's like
Thank you,
yearbook or
Potato.
something, or something's happening
Luke
right now.
Smith,
It just gave me a-
Jasmine Howard,
These are all seniors.
Lee Simpson,
That's senior pictures.
Kaylin Parker, Rachel Bauman, Aubrey Norton, Jacob Burton, Hunter Martin, Presley Thornburg,
Yep, it's all seniors.
Marianne Matt,
I saw an
Geraldine
email
White.
that came through and all these kids were listed on it. I just can't remember what it is. Something's going on. All right, so they make this, it says red, but honestly, it doesn't look red, it looks pink. Bases make them turn back to blue. And then the phenolphthalein, if you put that in a base, it turns like neon hot pink. It says magenta. It's not magenta. It's hot, hot, hot pink. You ingest phenolphthalein, you're in for a really bad visit to the doctor. Oh, it's bad. It can kill you. Phenolphthalein can kill you. Bases have a pH above 7. Acids are below, bases are above. If it's right at 7, that is neutral, that is water. 3 is below that, that's an acid. The pH scale essentially goes from 0 to 14.
That was after the litmus paper test.
Oh, you're talking about on this? Now he's trying to get in touch with me. Okay, so I missed one. Which one are you asking? 3?
Yeah.
Oh, that here. Let me go backwards. So that it makes the red go blue, which is really pink, and then it makes the phenolphthalein go hot pink. It says magenta, but y'all, it doesn't look it doesn't look magenta. It's like hot, hot, hot pink. All right, so the pH is above 7 up to 14. Acids are not the only thing that burns you. I don't know if you've ever been in the presence of ammonia or bleach.
Yep.
Those are bases. If you get them on your skin or in your eyeballs, you're in for a bad day because bases burn just as bad as acids do. Now, acids give off hydrogen. Bases, almost every single one of them, with the exception of ammonia, have got hydroxide on them. And that's going to be at the end. So not all, but most of them are going to have hydroxide as their anion, the negative ion. So sodium hydroxide, barium hydroxide. Yeah, we still need to be able to crisscross charges at this point to build formulas. That is the hard part. It's naming and writing formulas, but you're still going to crisscross like we did with ionics back from like what, the third 6 weeks? And then the last thing on here, salts. When you mix an acid and a base together, they make water, okay? And they make something called a salt, which is a metal and a non-metal, like sodium chloride. Normally a group 1 and a group 7 element. Sometimes it's 2 and 7, but it's a metal and a non-metal. The only weird exception is the ammonium ion, and it's been a long time since we've looked at this polyatomic ion chart. Oh, I didn't animate. Oh, yes, I did. I animated this. I just threw all this up. Okay, so we're going to do bases first. Bases are easier. Oh, what common household substances do you think? I know it's hard to write on the box if you got a paper. If it's an acid, common acids are vinegar. That's acetic acid, but we call it vinegar. That would be citric acid, like you have in citric fruits, like lemons and limes. Common bases would be CIT or IC. Common bases would be ammonium. That's the stuff that smells like cat pee, but it cleans really good. Sodium hydroxide is a common base. It's this sodium hydroxide. This is ammonium right here, not pneumonia, ammonia, NH3. And then common salts. Okay, so salt, sodium chloride. Let's see, potassium chloride, KCl, lithium fluoride, LiF. Group 1, group 7 element together. Those are your most common salts. All right, now, so the next one. I forgot I didn't put that into the thing. Hydroxides are named just like any ionic compound. Which element is Na? Sodium. This is hydroxide. You do not need prefixes, just like ionics. So NaOH would be sodium hydroxide. Very, 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 very common base. Which element's Fe? Iron. Obviously, that's hydroxide. Iron needs a Roman numeral. Guess what Roman numeral it gets? It gets how many hydroxides you had. Because we know this is a transition metal. We know this is -1. You sort of reverse your crosses. So that's iron 3 hydroxide. Barium does not need a Roman numeral. So what would you call this one? Barium hydroxide. And then this is a special one because this doesn't have hydroxide. This is ammonia. That's that stuff that smells so nasty that cleans everything. Which is why cat pee smells, because cat pee's got ammonia in it. Nasty, stinky stuff. Bases are much easier than acids. The only weird thing is to look to see if it needs a Roman numeral, and that's the short squatty part in the middle. Those are the transition metals. It's been a very, very, very long time since we've done this stuff. But it's coming back. Now we're going to switch over to acids. I'm going to put something over here on the board that's a little bit different than what's going to be on the screen. And with all the chaos that I've had this week, I haven't had a chance to put in the other way that I know how to do this. Binary means 2, means no oxygen. If it's binary, it's going to follow. I'm going to put it here. Because I honestly think most of you are going to understand the way that I'm used to teaching it better than this. But binary is no oxygen. And it's going to go hydro, the root of the non-hydrogen elements, and then ic, and then all acids end with acid. This is like what we did with the opener. All of them do this. They cannot have oxygen. Hydro, root, ic, acid. So the one that was the opener, HCl, is hydrochloric acid. Fluorine would be hydrofluoric acid. Hydrosulfuric acid, yes. So this one, yes, I have taught this way forever and ever and ever and ever and ever, and they do this way here because it works every single time. The only time you see hydro is if there are no oxygens, period, end of story. If there's oxygens, there's not going to be a hydro start. Oh, the only one that you have to watch the pronunciation is HI. The iodine, that's pronounced hydroiodic, not iodic. It's iodic acid. You don't want, I hear the giggles. I'm not trying to say a bad word. It's pronounced iodic. your information. Well, happens every year, just like in my first space class, we're learning about Lake Titicaca, and they're all like, ha ha ha. And I was like, stop it. It's what it's called. It's not my fault. But yes, they all chuckled. It's not my fault they named it that. All right, oxyacids. If they have oxygen in them, there are two types. On your polyatomic ion chart, do you remember the two different endings? There's two different endings that were repetitive in polyatomic ions. Eights and eights. That's how I've always taught this. So I'm going to show you their way, and I'm going to put my way over here. I honestly think most of you are going to like my way better because it never fails. You've got either one oxygen only, and yes, there are exceptions to the rule, which is why I do not like this way. My way doesn't need exceptions. Only one oxygen, most of the time, is going to be hypo, then the thing that's not hydrogen, so like nitrogen, sulfur, phosphorus, that stuff, then it's going to be us, and then acid is always at the back, always. If there's two oxygens, then it normally does not have a hypo prefix. It's going to have the root word, no hydro. So like chlorine would be chlorous acid if there's two oxygens. If there's three oxygens, like chlorate has, then it would be chloric acid. And there's only a few of them that have four, and I'm so sorry, but there are exceptions to this too. It would be, like in the case of ClO4, perchloric acid. I don't like this way because it has exceptions. So most of them are either going to be an it, no, an ite, or an eight from the polyatomic ion chart. And ites are going to be root, us, acid, and eights are going to be root, ick, acid. That's the way. I ate it, it's icky, and it's all right with us. That is the way I have always taught this for years and years and years. Yes, this works too, but there are exceptions. Acids are not fun. Bases are great. Acids are horrid. So HFO, this had one acid, which means it's going to get a hypo, or not one acid, one oxygen. Fluorine is fluor. The ending changes to us, and it's acid. Four oxygens gets a per. You're going to use the root from bromine, which is brome, and then the ending changes to ic, acid. So this is perbromic acid. I'm so sorry, y'all. Acids, I told you, acids are not fun. These are not fun to teach. Three of them don't get a prefix. Use the root from nitrogen, NITR, ends in ic, so this would be nitric acid. This is carbonate. Okay, so no prefix. The root from carbon, ic, acid. There is no carbonite. It's like a Superman. And that's kryptonite, not carbonate. What's carbonate for? Star Wars. When they froze Han Solo in the stupid thing.
Yeah.
That's where that came from.
Oh.
That's right, because that's all real. These follow those rules that azole does. Now, there are exceptions. You guys have some that are already listed on here. I'm still writing those out. No? Okay. So the exceptions, because with 3 oxygens, it's supposed to be, according to their rules that they teach here, sulfuric acid, okay? But this is sulfite, okay? Sulfate has 4. Ites change to us, not it. So the way that I have, and I'm not trying to give you 2 different sets of rules to confuse you, it's just this always works. With the SO4, according to their words, this rules, it should be per sulfuric acid, but this is sulfate, and 8s become X. So the SO4 is the sulfuric acid. PO3 is phosphite. Phosphorus acid. PO4 is an 8, phosphoric acid. And like, this is stupid. I ate it, it's icky. The 8 polyatomics become X with no hydro. And then it's all right, or when I was in high school, and this was so stupid that they used to go, "Ay." So it's all right with us. And so on the polyatomic ion chart, if it's an ite, it changes to us. No hydro. It cannot have oxygen in it to be a hydro. And it's, like I said, I cut my teeth teaching chemistry. Oh, there's one more on here. This is acetate. So acetic acid. This is common vinegar, which you can take the shells off of eggs overnight with, just for your information. And it's like a little water balloon without the shell on it. Not that I'm teaching you how to make the nastiest water balloon ever, but you can take the shell off an egg real easy from that.
I've done
It's actually really cool. You gotta be careful you don't squeeze it too hard because you'll pop the,
that.
Pop the
used it as a
membrane.
water balloon.
yeah,
My mom done that.
I'm sure. That's why I said, probably don't want to do that, but that's how you take the shell off an egg.
And it's
That's
so
because
cool.
vinegar reacts with the carbonate on the hard part of the shell and it disintegrates it. But it doesn't interact with that membrane. You know, like when you boil eggs and you go to peel them and it has that membrane, it doesn't eat the membrane up. It turns it into a water balloon, like an egg water balloon. Okay, oh, I didn't, oh, yes, I did. Okay, writing formulas for acids and bases. Hydrobromic acid. Oh, did I skip something? Okay, so I did. From looking at the name of a substance, what is the telltale sign for acids to know it's an acid?
It burns.
No, they both burn.
Mm.
It starts with hydrogen, and y'all, it's got the word acid in the name. It starts with hydrogen. From looking at the formula of a substance, how can you tell if it's an acid or a base? Most acids start with hydrogen, and yes, there are exceptions. Most bases end with hydroxide, OH. I didn't animate that into this. I apologize. Writing for, did I not? Yeah, okay, oh, go backwards. All right, so hydrobromic has no oxygen. We know all acids start with hydrogen, which is +1. Bromic comes from bromine, which is -1. Do they add up to 0? +1 -1, they add to 0? Is 1 - 1 0?
Yeah.
Okay, so you do not need any subscripts, so it's just HBr. All acids start with hydrogen, which is +1. Pretty sure I do aluminum hydroxide next. Aluminum from the periodic table, and I'm sorry those of you that are remote because I'm using the dry erase board. Aluminum is +3. Hydroxide is -1. These add to 0. Is 3 - 1 0?
No.
No! So you have to crisscross them, but you have to remember to put hydroxide in parentheses first. So that's AlOH3. Perchloric means it's the polyatomic that has 4 oxygens. So this comes from the hydrogen is still +1, the chloric part comes from the ClO4 minus 1. They add up to 0, so you do not need to crisscross extra numbers. Hypobromous would be hydrogen. Hypo means one oxygen comes from bromine attached to said oxygen, which would be HBrO. I didn't put all the charges on the thing. Sorry, I ran out of time. Fluoric would become from the oxygen that has 3. Fluor comes from fluorine, which is F. Your hydrogen is +1. Your fluoric is -1, so they cancel out to 0. Iodus would come normally from 2 oxygens. The iode comes from iodine, which is capital I. Hydrogen still +1. The iodus part is -1. Phosphoric is an exception to the rule. An ick is an 8. Like I said, I ate it, it's icky. It's stupid, but it works. So phosphorus, the phosphate is PO4 -3, hydrogens +1, so you need 3 hydrogens for the phosphate. Orange acids are bad. Copper's +2, hydroxide's -1, but protective parentheses around the hydroxide, the OH, and put the 2 outside of it. So like I said, I'm talking through the crisscross of the charge. If you do have a base, a hydroxide, and you need more than one, you've got to put parentheses around it first, because if you say CuOH2 without them, it's wrong. And then the last one that's on here, which I don't think I put on my thing. Oh, I see what to do on the next slide. Okay, so if you missed some of the top of this page, it said, from looking at the name of the substance, how do you feel if it's an acid or a base? Guys, if it says acid in it, it's an acid. If it starts with hydrogen, it's an acid. If it ends with hydroxide, it's a base. The only exception is ammonia. Okay, so if you miss the top 2, fill in the blank ones, that's these. And then if you do, so the last one, if you do mix an acid and a base together, it's going to produce what is called water, H2O, and it's also going to produce a salt, which is the metal from the base and the non-metal from the acid. That's going to be interesting to try to teach to you guys next week, because Monday's asynchronous. Tuesday, I know for sure I'm not going to be here. Wednesday is up in the air. Sort of depends what happens this weekend. And I still have people that did not do that test that was from Tuesday, Wednesday. I had extended it again. Still have people that didn't do it. Okay, so the assignment today, this nomenclature stuff, I'll walk through a couple with you. So, no oxygen are your hydro acids, your hydroic acids for that matter. So, which ones do not have any oxygen in them whatsoever? On the assignment.
What was the question?
Which of them have absolutely no oxygens and are hydroic acids? No oxygens. But which number are you? No, on the assignment, which numbers are going to be your hydroic acids? Well, look at the thing. Which ones don't have oxygen in them?
10.
10 and 1. So those are both hydroics. So sulfur actually keeps its whole name as sulfur. So it would be hydrosulfuric, and then don't forget the word acid. The ones that have one oxygen in them, like not hydroxide, but just oxygen, like number 3. That's the only one that I see on here right now. Those are your hypo. I didn't put it here. Let me rock back to the right slide. Oh, I just dropped the expo. Rock back to the right side. Right. So the one like number 3 is the hypo root. Okay, that would be from iodine, iode, and then those are us's. Most of them that have 2 oxygens, not the hydroxide, I don't see any of them. Now, there are exceptions on here, which is why I do not like this. I like this better. But most of the exceptions are already built into your notes to be able to tell you what to look out for. And then down on the bottom, it says to write formulas for the following acids and bases. Guys, if it says, oh, that's sort of not lined up for number 8. I apologize. I'll fix that. If it is an acid, the hydrogen is +1. Then you're going to have to figure out the negative ion. If it says hydroxide, then hydroxide is OH with a -1 charge. If you see a Roman numeral like number 6 at the bottom, that lead is +4. Sorry, number 8 is sort of, I'll fix that. That's what happens sometimes when I change them from a Word document to a Google Doc. I don't proof for it. So pay attention to the exceptions, which are these. If you see any of these on your paper, top or bottom, I would do the exceptions first, and then I would do the ones that follow the rules second. Acids are nasty, y'all. Like, the nomenclature is nasty. The building of the formulas is nasty. Wait till I get to try to teach you how to calculate logarithms with pH next week, because that's nasty too. This is one of the last hard sections that we're going to have this year. So let me check on my list. Let me see. We got, give me just a second.